Hello everyone and welcome to Entry-Level Exploits. The concept of the series is simple. Find a bug, submit a valid report, and get your first bounty. Once again, we're partnering with BugCrowd, and so I just asked them, hey, what are the most common first vulnerabilities that people find on BugCrowd? I'll make videos about them. And they actually gave it to me. They were like, here you go, here's the list. So what I'm going to do is I'm going to break down all of this, the BugCrowd first bug top 10, and show you how to find them. We're going to cover the TLDR of the vulnerability, what you need to know, give you a practical step-by-step methodology for you to both find and exploit, as well as have a hands-on practical demonstration, so you can replicate it on your own targets and actually build your methodology. My goal here is simple, to get you to unsubscribe to my channel and never watch my content ever again. Welcome to this week's video on reflected XSS. Okay, so let's start with the basics. Cross-site scripting, or XSS, is a vulnerability where an attacker can inject malicious JavaScript into a web page. When we first learn about this, and when we demonstrate it to clients, often we use a really simple pop-up, like this. You press OK, and that's it, that's the only impact. Actually, the alert box itself isn't the danger, the ability to inject JavaScript is. The actual impact of this vulnerability is really what you can do with that JavaScript. With XSS, you can do a lot more than that, primarily around things like account takeovers. Now, with that, there's like an asterisk attached to it because sometimes you're limited to how many characters you can use in an XSS payload. Not every XSS is exploitable to that degree, but you can do some pretty cool stuff with it, whether that's stealing cookies on older websites, whether that's actually sending a request through the JavaScript to a page that changes their email or their password, essentially taking over their account, or changing the page to turn it into a phishing page. And that's really why customers care. It's not so much that you can get a pop-up box to appear on the web page, it's about, hey, this could potentially lead to a full account takeover. Now, especially for your first bug, you're not going to get a full account takeover. Like, it's not going to happen, it's fine. Instead, we're just going to focus on getting this pop-up to appear. Now, fundamentally, an XSS happens because a website trusts the user input and just reflects it onto the page. Now, there are a few different types of XSS. Today, we're going to be focusing more on reflected XSS, but we're going to talk about stored XSS in the future. What reflected XSS means is that instead of the payload being saved in some kind of database, instead, it's reflected back from something like a parameter in a URL. It doesn't sanitize the parameters, so it doesn't go through there and remove all the characters that might be HTML. Instead, it just reflects it onto the page. Now, this brings us to one of the hardest parts of this, which is self-XSS. Self-XSS isn't a type of XSS, not really. Instead, it's a classification of the impact of a vulnerability. An XSS vulnerability can be considered a self-XSS if only the person who can trigger it to appear is the user themselves. And that means both reflected and stored XSS can be considered self-XSS. For example, if you've got a stored XSS on a page that only you can access, maybe you're in an admin control panel and you go into the notes field and you add a note to a user, and boom, you've then got an XSS. That's only really worked for your account, and also because you're an admin, there's not a lot of impact there. Same kind of situation, maybe you're testing an e-commerce store, you've got an item description, and you put an XSS payload in there. Again, it's only going to affect your shop and therefore your users. There's no wider impact there necessarily. Think about it. If you found an XSS by maybe editing your profile page, but it's on a field that's only ever visible to you and your private settings, who actually are you attacking? The answer is yourself and only yourself. And with reflected XSS, the problem is the same. For an attacker to exploit a victim, they need the victim to already click on a crafted malicious URL. That already adds a level of social engineering. And then on top of that, you've then got, okay, this parameter is maybe a hidden field in an admin panel, right? The attacker can't build a link to access that. You can't easily tell somebody to do that. The only person who can input the payload is the victim. And at that point, you're better off just asking them for the password. You can't create a scenario in which the attack works on like a real victim. You can't demonstrate the impact. Theory over, how do you actually find them? So step one, you're going to look for some kind of reflected input on the page. Now, typically this is going to be in URL parameters, and typically it's going to be on things like search functionality. Once you found one of those parameters, and honestly anything you can control, you're going to start by putting in the simplest payload, because honestly, most real XSS and real clients are not going to get caught out with simply script alert 1. Instead, there's going to be some kind of filtering in place that you're going to have to bypass. So type it in, script alert 1 script. So when it inevitably doesn't work right away, you're going to right click on it, view page source, and look in the browser's inspector. You need to figure out how the server actually interpreted that payload. How did it render it on the page? Did it remove script tags? Did it HTML encode angle brackets? Understanding the filter is the key to bypassing. And this is where you're going to get creative. I actually highly recommend this book called JavaScript for Hackers, because it has so many examples of how to do this and like ways JavaScript is weird, because fundamentally, like, we need to get creative. First things first, one of the simplest ways that organizations stop XSS is simply by blocking the script tag. So if you get that, you can switch out script for an image tag which has an on error. So you can use something like this payload here. You might also be able to do a on load, like for example, this. Sometimes filters are case sensitive, so it's looking for script or lowercase, so you can try something like this. If the web page has some kind of like weird encoding where it's double encoding things, you can try using HTML and URL encoding to hopefully bypass the parser, something like this. Now, sometimes clients will actually block the alert, which I always find quite weird because the alert isn't the main impact, it's just how we verify it. So if you have something like that and you can't have the word alert, you might be able to just build it from character codes like this. So realistically, as you're doing this, you're going to use a fuzzer with a large list. Now, personally, I find it's more effective to actually figure out what the filter is doing and be able to actually start to go, okay, do I need this? No. Do I need that? No. Do I need this? Yes. Do I need that? No. And then choosing the right bypass from that, because these XSS bypasses can get absolutely wild. So here is something that some dev has created where he broke down an XSS payload, and the amount of like bypasses that are in there is crazy. One way you can bypass as well, if that XSS is blocked by some kind of WAF like Cloudflare, you might be able to find a Cloudflare bypass that will work for any Cloudflare website. If they don't have a second like parser, a second filter on top of it, then you might be able to get it that way. Now, realistically, for your first bug, the best advice that I can give you is to look for DOM XSS instead. So DOM XSS is where the vulnerability exists only in the client-side code, because it's less the server is the problem, but the page's own JavaScript is. So here's how it works. You have a list of sources that you can provide input into, and then you have a list of JavaScript sinks. That's where your input ends up. Your job is to read the website's JavaScript and find a path from user input in some description to one of those sinks, so in HTML. Now, I find commonly this happens a lot where you've got a web page that's like saving your previous input and then you refresh the page and it fills it in before. That can be a really good way to find these. Now, the reason why I recommend DOM XSS for beginners, especially when you're testing reflected XSS, is actually because it requires you to read the page. And this is where we get into like bug bounty meta. You're just going to have less competition because fundamentally XSS is so competitive. I really cannot tell you how competitive it is. And there are folks who literally will be looking for new scope being released and immediately test every single user input point for cross-site scripting. So getting easy wins, you're not necessarily going to find them. You need to have that more creative approach first. Okay, so how do we actually know when we've found a genuine bug, fundamentally, that a program will actually accept? So genuine reflected XSS is where you as an attacker can create basically a single link that you can send to the victim. Like, you want to be able to include that in an email, they click on it, boom, done. That is how it should be fired. When they click on it, the script executes in their browser in their session. You can then do something like steal the cookies or use something like XSS Hunter to take screenshots of their account or whatever, because we could just take that URL, send it to somebody, and boom, that's it. That's our payload done. Now, how do we know it's a self-XSS? Now, a self-XSS requires the victim to perform some action, and it's not as easy as just getting them to click a single link. There's going to be multiple steps there. So if you would say have a vulnerable field where you need to copy a payload, paste it in, and press save, you can't build a link for that. That's not going to be one click, then exploit. It's always going to take more than one step. So the litmus test for, hey, is this XSS worth reporting, and is this actually going to be a valid vulnerability, is, can I craft a single URL that another user just has to click on? The answer is yes, that is a valid bug. If the answer is no, it's a self-XSS, there's no point wasting your time reporting it. The client isn't going to care, you're just going to get disappointed. All right, let's put what we've learned into practice and actually do this. So I'm using JuShop as an intentionally vulnerable application. So the first thing we've got to do is find some reflected input. Now, the classic example and kind of the most obvious example is going to be a search bar. So we can go into the search bar here and we can search for something like, and if you look at where it says search results, we can see the word Apple here. And if you look at the URL here, you can see the word Apple as well. So we can control that. We can send a single URL to somebody. So what are we going to do? We're going to start out by just adding some HTML here to see how it actually handles HTML. So I'm going to do Apple and Apple like so, press enter. And here I can see the results. So if I right click on this and then inspect, you see how underneath the span ID, it's showing the bold tags here and then the word Apple. That means it's being actually understood as HTML. That's a good sign for doing XSS. So we can go in here and now try a very simple script alert one payload. So I'm going to go into here, script alert one script, and then press enter and see how this changes. So you see how the search value here has got Apple, and then at the script, it's got this kind of gray color to it. It means it's not being interpreted as like valid HTML, which means the script is not working. Now, this can be for various reasons. Because the bold works, but the script doesn't, that could suggest that HTML is allowed, but not a script tag. So we need to have a look at something that shows us different ways of doing things. So my favorite source for this is always payload all the things. And then we're just going to go scroll down to XSS. And down here, it will show us like a bunch of different ways to do it. So if we scroll down to something like common payloads, we can see a bunch of other options that don't use the word script. So we could try one of these image payloads. We could try an SVG payload. We could try a div payload. We could try body, or etc, etc, etc. There's a bunch of different ways to do it. But for the moment, let's not worry too much about that and just understand how this input is coming together. So I can see it changes the URL here. So if I go and turn Incept on, if I now change this in some way and refresh the page, we can see this value has changed, but we haven't got any calls to another web page. So that suggests that this is something that's being done entirely within the JavaScript on this page rather than coming from outside. Now, how do we actually begin to analyze JavaScript though? Because we've got an ID here in the span, this is going to be something that references this ID. Whenever you want to look into the JavaScript, you're going to go into the debugger here and you're going to open up this part here. Now, it might all be on one line. If it is on one line, you're going to click on this button here that will expand the JavaScript. And we can do a search for the code we're looking for. Now, because this is a CTF website and for learning, we need to skip past all the hints and all the cheating. And then we can begin to see how it's actually generating these results. So if we have a look here, you see how we've got this inner HTML. This is probably the function that's being called on this search value. So we know it's using an unsafe sync. Now, if I scroll down here and see where else it might be using it, I can see some filter tables and I can see some other stuff in here. So if we see this value here, this bypass security trust HTML, we can actually go in and have a look at that. Now, if we look for this and we just scroll down here, you'll notice that one, this sanitizer is being used in lots of things. Two, the code isn't in this file. So instead, we're going to go to vendor and we're going to search it here instead. Now, vendor here is just a bunch of libraries that's being called. So if we scroll down to sanitize and then bypass security trust HTML here, we can see what's actually being blocked. And notably here, you can see the script is being blocked and you can see unsafe value used in the script context. So we know that's going to be blocked. We know it's a DOM XSS. Now, all we really need to do is try different payloads. So let's try an image payload, for example. We can see we've got a result. So we have been able to actually get the XSS working because while the script tag was blocked, the image tag was not. We know we're using .inner HTML. We know that's insecure, hence why it works. We know this is reflected XSS because all we'd need to do to exploit a user would be to copy this URL and paste it into their web browser. All we'd need to do is copy this URL, it's only one URL, get them to click on it, and then the same XSS alert would fire for them as well. That's a really simple example, and certainly there are tons of other ways of doing this. If images were blocked, we could try SVGs. If SVGs were blocked, we could try HTML5 tags. If it was stuck in the JavaScript, we could use this DOM-based XSSing. And if you want to make it a little bit easier, there are intruder files that can do all of this. But again, actually looking at the HTML and understanding how it's used, looking at the JavaScript, gives you such a massive advantage from a first bug perspective to find a unique bug that nobody else has found yet. So what kind of client should you be looking for when it comes to XSS? Honestly, any application can have XSS. XSS is one of those vulnerabilities that isn't more common in certain places, less common in others. I will say that typically for the kind of stored XSS we've been talking about today, it is going to be really competitive. There is going to be a lot of people looking for it. So to have that edge, you have to be strategic and really look for new targets, new scope, new everything, right? Like you want to be able to take a new program or something that's just happened and be like, okay, I'm going to go in and test this all for something like reflected XSS. Again, you're looking for where the fewest number of hackers have had their eyes on the program. So we're on BugCrowd now. What kind of programs are we looking for? Well, we want something, one, has some kind of web-based product, and two, we want something that's interactive. So some things that probably like spring out at me is that Okta, while yes, very interactive, probably has a lot of JavaScript, is going to be insanely competitive. So as a new bug bounty hunter, while we might look for something like, I don't know, maybe like IDORs or something with quite a lot of manual testing, Okta is just not worth looking at. MyFitnessPal could be a good one. I don't know how much of this is like a web-based infrastructure, but that could be a good choice. I'm looking for like things I've heard of as well. Just Eat Takeaway could be a good one. So if we go in here now and just have a bit of a scroll down, we can see they've got some API assets and then they've got a bunch of their web pages. So if we have a look at justeat.co.uk and we were to go in here and potentially we just look at inspect element, we're probably going to see this is going to have quite a lot of JavaScript being loaded. Oh yeah, there's tons of JavaScript here. Now that's a really good sign that this might be a kind of reflected XSS that we can find because we can do that manual analysis of the JavaScript. Now, I don't recommend using AI copying the code and being like, tell me where there's a vulnerability here. It's not going to work. It's going to hallucinate. But what I do recommend is using it to better understand what you're looking at, particularly when the JavaScript is minified like this. It can be really hard to understand. Some other programs that I'd have a look at in here, we've got Glean. Now, Glean is an AI-powered tool that essentially is used as like a homepage and can search through a bunch of different products. Going to have a lot of JavaScript, but it's probably only going to work in the context of a single user accessing themselves. So while lots of JavaScript, limited impact outside one user. Comcast here. Now, Comcast is streaming. If there's any kind of streaming, there's going to be a lot of JavaScript there. There's definitely going to be like a lot of stuff happening. So this might be a good choice. We've got Skyscanner. Skyscanner is a travel company. Again, very highly interactive JavaScript pages. Navan is the same, also a travel company. If you're searching for flights, that's going to have a lot of different pieces of user interaction, and that could be a great place to get started. Pinterest is similar as well. Tons of user interaction in there. Something like Quizlet, lots of JavaScript interaction. When it comes to finding these reflected XSS that are actually going to be valid vulnerabilities, you are looking for programs that are very active, they're very engaged, they're putting out code all the time, they're not leaving assets to die. You're looking for something that has quite a lot of JavaScript, not necessarily because the amount of JavaScript tells you anything, but the more difficult it is to analyze, again, we're thinking bug bounty meta, bug bounty strategy here, it's going to have a lot less competition. So the other option, which I think is the better option, is to go deep on JavaScript. Do not sleep on JavaScript. Instead of looking for your surface level inputs, your little forms, your little search that everybody else is testing, instead open developer tools, read the JavaScript, look for DOM.XSS. You even use AI if you find that helpful to explain the code to you. But honestly, when you look at bug bounty programs and you look at what's actually being rewarded, it is all going to be like DOM.XSS, 100%. And I know this because I found one XSS vulnerability in the wild, and it was a DOM.XSS. So again, that manual work gives you an advantage. The knowing JavaScript gives you an advantage. And when it comes to bug bounty hunting, yes, you have to know the vulnerabilities. But if you want to beat luck, if you want to be able to get things consistently, you need to also have a really low competitive approach as well. So that's the difference between a real reflected XSS and self-XSS. Honestly, it all comes down to one thing, which is, can you realistically attack a victim? Focus on the impact, dig into JavaScript, and you will find bugs eventually when it comes to XSS. Now, is this going to be something you find right away? No. XSS is similar to idols in a lot of ways. It is about testing everything. The more thorough you can be, the better. But if you're persistent, if you work to understand that JavaScript at a deeper level than just copy and pasting payload, I promise you will find one eventually, because I did, and I don't know anything about JavaScript. Thank you very much, everybody, and I will see you all in the next video. Bye, everyone.